Today we're going to talk about step functions. Sammy and 5 friends want to go bowling, and they decide to rent a lane by the hour. The bowling alley they go to charges $20 for the lane and a rate of $10 per hour. So we want to write a linear function that models the cost to bowl at this bowling alley. Well, first, we have y equals. Now, y is going to be the cost, and we know that it costs $20 just to get the lane, and then it costs $10 for each hour. And x is going to represent the hours. Now we want to graph this linear function, and then we're going to compare the linear function to the step function that truly exists when you go to this bowling alley. So if we're going to graph this, we're first going to put a point here at 0, 20, because that's the y-intercept. And then we're going to go up 10 every hour. And so our graph would look something like this. And me being the awesome video guy that I am, I went ahead and made it a nice, clean, straight line for you. We need to, however, take this linear equation and look at it from a step function point of view, because in the real world, that's what it is. First thing is we're not going to be paying $20 if we bowl 0 hours, so we're actually going to bowl or pay $0 if we bowl 0 hours. And then if we bowl 1 minute, we pay $30. So our step function starts to look like this. And then right after 1 hour, it goes up to $40. But at 1 hour, it's still only $30. So our step function has an open circle because it doesn't include that point, and then it's a flat line. Looks like staircase, stair steps, step function. So again, being the awesome video guy that I am, I created a nice clean graph for you. However, because this step goes up at a constant rate, we can write a special equation for this. And it's called either a floor or a ceiling function. Now, if you notice, this is the type of diagram that I put on that graph. So this is a ceiling function that we're dealing with. So we're going to take our linear equation, y equals 20 plus 10 times x, and we need to put the ceiling function around the x. We don't put it around the 10 because we put it around whatever the 10 multiplies to. So this means, so that if I have 4.2 hours that I bowled, I got to pay for all 5. And so we're going to multiply that 10 by the 5 that ceiling function works out to be. Then we got to look at the possibility of the situation changing. Maybe the rate changes. In this case, that same bowling alley, they understand that some people don't bowl the whole hour. So maybe they want to see, pay a little bit less. So that same bowling alley, they offer a different rate. They offer every 15 minutes you can pay $3.50 as opposed to every hour paying $10. So we need to write a linear function to model this new rate. Well, that's going to be the same cost to rent the lane plus $3.50 for every minute divided by 15. And because you know that you're going to be paying for every block of 15 minutes, that means you're not going to be paying in case there's like a 17-minute time frame. You're going to be paying for 30 minutes if you go past your first 15 minutes. So it's going to be another step function. When we do the step function, we need to make sure we put the ceiling or floor brackets around only the thing that's governed by the minutes. So when we write our function, step function, we have y equals 20 plus the $3.50 is not controlling the minutes. That is what is multiplied by the minutes. And it is a ceiling function again, and it's minutes divided by 15-minute intervals. And that is our step function, the ceiling function, that is generated whenever we go bowling for 15-minute intervals. Now let's see another step function. This scenario rates the size of a hurricane based on its wind speed. The Saffir-Simpson scale says Category 1 hurricane is a 74 to 95 mile per hour hurricane. Category 2 is 96 to 110. Category 3 is 111 to 130. Category 4 is 131 to 155. And Category 5 is 156 and above. However, what should the actual intervals be? If you notice, there is a discrepancy between this 95 and this 96. Because what if the wind is 95.5 miles per hour? That means that the hurricane Category 1 should actually be 74 all the way up to, so it's going to include 74 and go all the way up to 96, but not include it. Category 2 is going to start at 96 and go all the way up to 111, but not include 111. So on and so forth. So this is going to be a place where we have a closed circle all the way to an open circle. So this represents, graphically, it's going to be a floor function. However, these intervals are different range of values, so it's not a constant function that we can write. So there is not going to be a rule that we generate for this function. We're just going to graph it and show you what it looks like. So 74 is approximately right here. And then 96 is approximately right here. However, for 96, there should be an open circle. And then for the next part of the graph, a closed circle at 96 on hurricane Category 2, all the way up to 111 with an open circle. And because I'm an awesome video man that I am, I have created this graph for you, nice and cleanly. This is the step function graph of the Saffir-Simpson scale for hurricanes versus their wind speed. Ladies and gentlemen, that is step functions. I hope you got as much out of this video as I did making the video.